Thanks, Daniela, and welcome everyone to the November webinar where we will be looking at IFC files and validating open industry data formats and a use case using FME. Just first, a little bit about myself. I'm an account manager and pre-sales consultant here. Before One Spatial, I was in hotel tech sales, so quite the change. I've been at One Spatial since 2020 and started using FME not too long after. I'm based down in Melbourne nowadays, and yeah, was originally from Sydney before then. Just quickly going through the agenda, we'll discuss what open industry formats are and what IFC files are and how these read into FME. Then we'll mostly look at a use case of validating an IFC file and translating this as well, and some use case improvements that have actually happened from one of the more recent updates in FME form. So what is IFC and what are open formats in general? So open industry formats. A bit of context to this is that there was closed formats that were blocking collaboration where each tool had its own file type, and obviously trying to share this across different consortiums was becoming difficult. And within these transfers, data was getting lost, just like most sort of translation pieces that you have, particularly when it gets kind of scaled up. Inconsistent standards, which we're all sort of familiar with, and being locked into a vendor meant that users were pretty much stuck in what they could do, and then any plan for sort of change was well into the future. It might have been a little bit unrealistic for the current project. So a solution to this was to try and enable interoperability and in a large sense, so we can share data easily, particularly in projects and large companies that have a lot of moving parts, and sort of counteract the other reasons that were creating the reasons for industry formats, which is preserving data, standardizing the format so it's the same for everyone, and reduce the costs that this was causing for projects. So with global industries, consortiums, and collaboration projects were the beneficiaries in this one. So construction and mining are the two ones that will be sort of mentioned today, and most particularly construction with IFC. So this is just some stories or some examples, I should probably say, that I found on some US sites that I've got down below that sort of can provide some monetary reasons as to why things like IFCs were created. So a lot of these that you can sort of read through were mainly just around having to spend money on API customizations or just delays in projects and fines that they've incurred or additional labor. That's the record, I guess, resulted in financial costs that something like IFC tries to avoid. And probably the top right one there, you can see it's a bit of a summary of saying 5 to 10% of project costs is around some sort of interoperability failure. So yeah, that's exactly there's some reasons why IFC might be around. So just if you're not quite familiar with IFC files, I'll just take a slide or two to quickly run through what they are. They're designed for the AEC or the construction industry and follows an official standard from the ISO organization. So the encodings are either STEP, which is the ISO based, or more typically XML. They're object orientated, so they're describing the relationships, geometry, and then the properties. And object orientated works quite well because many softwares are object orientated. So the interoperability is a lot more easier to implement. And just got a little image here that describes or just shows you what sort of happens with an IFC file or what the flow is supposed to be. So you can see that going in the middle is sort of the open format and the different encodings you can have. But through the XML is where you can start translating it into your BIM tools and start using it in your own native environments as well. So I'll just touch on now on IFC files and also some related files with it as well, and how they read into FME. So how does FME process an IFC file? So FME is able to read IFC files. The typical structure in IFC is it has a header, a bit more metadata type of information, and then it's got entities, property sets, which is more of a categorical like information, like fire rating, which is what we use in an example later on. The quantity sets, relationships, which you'll see a lot of later on as well, and then also the geometry. Each element object is read into FME as a feature type or a layer class, if that's a bit more familiar to you, and attached to the element linked by the global ID, which you'll see later on. Geometry, if it's there, and property sets, quantity sets, and relationships. So it does a little bit of the legwork for you in attaching that onto the feature, as opposed to how it is structured in the file. So this is an example of one being read in to FME and having a look at the information window. And you can see they read some of the values in, like you can see at the top where it's an alignment from part of a bridge. And all the nested values is where it has all the relationships of everything that it relates to. So just giving you a bit of an idea there. If you've tried to look at IFC files like I was and the workspace was on that we'll go through before, there was an old IFC writer, IFC reader and writer that was used, but there's actually a new one that's come out that's quite functional, and I'll take you through it now. So this is what it looks like in the reader, where there's quite a few functions here that makes that takes a bit of the legwork out of doing any doing some pre-processing. So it's going to read the definitions in of the property and quantity sets and have them on. You can control what geometric representations come through. There's a couple options there if you want to restrict it. And then also you can use a search envelope, which is new, I think, and validating the IFC model on read is also going to be good too, where you can set the IFC model where I think it's configured for 4 and 4.3. So if you tick that, it will validate the schema that's coming in against those versions of IFC and make sure that you're working with the proper IFC file before it comes in. And then the writer over here, you can actually specify which version that you want to write it out of, and with the same validation function at the bottom to make sure it has the same structure, and it gives you the ability to create a header as well. So IDS files, these are files that are used basically to set a data standard and specifications for the IFC file. So they stand for Information Delivery Specification, and it's an XML file in its structure. So when it gets read in or how it's treated is according to XML. Some examples that I've got here of specifications that we're actually going to see in a second is that it must fit a regex for a fire rating, which would be a property check. Then you can also check relationships, rooms are contained within floors. You could do other things on the property set, like in the quantity one, doors must be certain heights or things like that. However, unlike IFC, there's no actual official schema for IDS, but there has been recommendations that are starting to come out as of June last year. This is an example I just kind of whipped up in AI just to get you an idea of what an IDS looks like. So the root element that it's referring to is the top one up here. So it's got more of the metadata stuff and referring to the schema URL and where you can find that. Then the next one is providing actual metadata, so authors and the title of the specification. Then you've got the actual specification here, and you can see how the XML structure sort of breaks down into the applicability of what entity it's after, and then the actual requirements of what that has to be. So referring to the property set, and then the actual pattern of the regex, and you can see how it kind of goes down into property value and then back up to close off the specification. So validating IFC with the IDS files that we can do in FME. So FME will read in the IDS through the XML reader because there's no native reader for IDS files, then it gets flattened out into the in terms of specification into the attributes from what we can see the labels from before in the example. And the key is to inspect the IDS first to understand where the info we want is going to sit once flattened. And this is particularly important because there's no actual official schema yet. So there's no actual sort of point to refer to. Obviously, you'd probably tell them to use the recommended one, but it's still something to be careful about. Once you then have it in, you want to clean it and manipulate it and trim it back to keep the key features that you're after. And then the validation of using that to validate against the IFC requires merging onto the IFC, just because with FME, if you want to do attribution checks across two data sets, you have to merge them. And to doing that, entity is probably going to be the best way to do that, but each use case is going to be different, and you probably want to check that out and do a bit of a data discovery before you find the best way. This is an example of an IDS that's been read into FME. You can see here that I've just put in a red box where the specifications have come in as list attributes. And then you can see between the top one, which is around the project, basically saying project shall be named correct. It doesn't, I should probably have dragged that all out, but basically just says it needs to have a name or a value must exist in a more simplified sense. And then the bottom one is on the wall, and it's referring to the fire rating. So that's what I was sort of been referring to throughout this. And you can see quite right at the bottom there, it's got the property set wall that it's referring to from the property set, and the regex at the bottom that the fire rating has to follow. So this use case in FME, which has already sort of been pieced together already. So this is the IDS that we're going to be using in the use case. So I've been alluding to it a little bit through the webinar as well. So this is the first specification at the top, which is in the reference to naming the project. This one is at the bottom. The second specification that refers to the fire rating must match the regex of the value, which is, you can see a little bit lower down has the pattern value there. This is the specification. So these will be, you can see the names there that they'll be flattened out, and this is how they'll be identified within FME. So you've got the specification for both there. You've got the entity and what they apply to, so the project and then the wall, and then the requirements for that. So unfortunately, it doesn't follow the same schema as both. So you can see the top one just says it refers to the name, and this is it. That's the value it can have as test. Whereas the bottom one says it's more referring to a property set. Because it's attached to the feature as opposed to the project entity, which is not a physical feature. So it refers to the property set and then has just a little bit of a different structure that identifies what the property is within that property set, which is the fire rating, and then what the value of that is, which is actually also recognized there as a pattern, just for identity purposes to know that it's not an actual physical value, and then has the regex for the fire rating. So now I'll go through the example that IFC file example that we use, which is just 4 walls. So it's pretty straightforward. This is in the middle is it being read in FME, just the geometry. On the right is the entities that get read in. So there's a total of 16. And then on the left is its actual raw form, which is actually the step format. It's not actually XML, which I thought might be a bit more interesting to have a look at. So you can see that it's identified at the top, the ISO standard that it's according to, and then the other things here like a header, end section, and data are quite typical of step formats. Some other things here is I've just got pointing to this because it's a good use of, on the left you can see that it's actually got the numbers of each line, which is an ID number. So where the green arrow is it says IFC rel aggregate, so it's the relationship aggregates. So within that, you can kind of see there's an ID number, some dollar signs, which is some rooms to put in attribute values, but then it's actually got the items that it is related to within it. So that's a way that it can reference itself. So number 12, it's actually referring itself to the IFC site that it's related to. Where you can see here is this is an IFC, what I've got in the pink is an IFC wall, so it's an actual physical feature where that's actually linked to. And then another one down here, which is line 44, which is another IFC wall, which is second listed. That's actually related, if you look over to the right, the first two IFC walls is that's where they're linked. So if you can see the unique IDs, they're both the same, referenced within the line. So that's just a bit of a link between the raw file and sort of how FME is reading it in. With all of these sort of condensed though, it just makes, I'd love to show you the table of how it all reads in, but it's just huge with so many attributes and so many empty values just because there's so, different amount of entity types and that are coming in. The FME workspace. So this is what it looks like. It's fairly compact. It's not really too big. You got the top part here, which is processing the IDS. So there's just a few steps and hoops because it's not as structured for each specification. Then the bottom part is processing the IFC and getting the property sets basically onto the features. Then validating them, which is bringing it together. And then separating the two data streams for for validation. So preparing and processing the IDS. This I've just got a bit of a zoom in on the bookmark. So the attribute renamer, I'll just go through a couple of the ones, not through all of them. The more key ones. So the attribute renamer is obviously just trying to get a lot of those default values into something more readable. The attribute creator here, which actually creates the rule categories, which is going to be used later on in the validation process. And then this attribute creator as well, which changes the entity types to a value that's going to match with the IFC. And then the final one here is renaming all the attributes so that when they merge, all the IDS attributes will be maintained when it's merged across. Now moving on to the processing of the IFC file, it's pretty straightforward, more or less just bringing in the file and using the test filter to spray out the entity types. And then from there, what we're really just wanting to do is to get the properties set and merge them onto the walls and the actual features of the file. So how we're actually going to do that is we use that attribute creator, which I've just got a bit of a screenshot here, pulls the values from the IFC property set. So you'll remember in the XML file, the property ID property set ID, it will actually reference the ID value from the wall. So the FME picks that up and it stores it as a list attribute. So all we just have to do is just create a new attribute that's got the property set ID and just pull the value from that list attribute. And that essentially creates that. And then we've got a shared attribute to merge the two onto. So, and this is the example of just what I've sort of described. So you can see in line 56, it's got the property set of the value. And then if we look over to that feature, it's got it pulled into the list there as well. And then when we go to actually merge it, then we're able to use both of them and we're on our way. Okay, so the validation part. What I'll also bring into this as well is, apart from just the validation screenshot, is the IDS screenshot, because a lot of the processes we did here are now going to be used in the validation. So this feature merger actually that uses the entity types, this is possible from the attribute creator that we had in the previous part that is actually supplying that screenshot there that created those values to be used. And then also the attribute filter that's going to split up the data streams uses the values that was created from that attribute creator in the previous IDS part. So doing the validation, particularly for the fire rating, because the other one is the project is more or less just testing that a value's there. This part is being built dynamically, so it's quite interesting and worth explaining, and can obviously be used in more of an automated scaling way. So this is the screenshot of it, and it's got sort of a different value reference, and I'll break it down a little bit for you of what this sort of means. So this is the feature that, or one of the features that we've got from the walls in the information window. So if you sort of break the left value logic down into two parts, you've got, so it wants the value of the rule def attribute, which if we look to the left is fire rating. So then if we look at that more holistically, it's saying the value of fire rating, which actually is over here. So it's dynamically searching for the value reference in the IDS, and it's looking for that throughout your IFC file that you've just merged on. So now it's saying, all right, well, we need the value of that of fire rating, which is what what we're testing. And then you just move on to the rest of the logic, which is okay. So does that value contain the regex of rule def values, which is here. So that's just a bit of a structure of how the validation is happening and how it's happening dynamically. So the failed IFC wall entities, because that was the purpose of this workspace, was just to report on the ones that haven't passed. In this one, it was two of the walls, which was wall 1 and wall 4. If we look at one of the walls in the information, we can have a little bit of a look down, and we can see fire rating, and the value there obviously doesn't match a typical regex for a fire rating, so that doesn't pass. And if we actually look at the other wall, which is wall 1, nothing sort of sits there, which is a bit, well, there's no fire rating, which makes me think, has it missed something? Has there been an error? But when you actually look at the workspace and the values read in, only 3 of the property sets came across. So that automatically was going to tell us that something didn't have a reference to a property set. So that's actually where that use case or workspace that we made sort of ends. It was more or less just we found the failed features, and that just went into a logger, more or less just to show that FME can sort of use an IDS to validate some features, which was pretty cool. So now, in the purpose of this webinar and wanting to talk about IFC, it's because there's been some improvements that I've already talked about, being the new reader, but actually applying those to the workspace that we just went through, I thought would be definitely worth outlining that if you've had to be doing IFC before, it's, I think, a much better process now and can be used a lot more effectively. So the new reader has an improved schema, and why that's important is because having a better schema means that when you write it out, you're going to have it just makes it easy when you write out because it's already got all the proper attributes that you need. So a big one's being the element ID. So the numbers that you saw on the left, originally that wasn't read in by the depreciated reader, but is now an attribute that's read in FME. So this is an example of that. So the exact same file that we've read in now has it listed as an IFC element ID and has that value next to it. IFC name, just has the structure of the naming more consistently. And then also the property set info explodes automatically into the attributes, or we can set that up as I showed you before. But if you do, it's actually already there. So just my sort of poor image scaling trimming skills, but you can see it actually already marries up. So in the workspace that I just showed you, there would have been no merging process. We just would have been able to read that in and immediately merge it onto the IDS. So the other big one is the BCF reader and writer. So I previously tried to use this, and it was very tough to use. I'll be really honest. They had to set up the folder structure quite. You had to be very creative with it, essentially, and it required a little bit of work. But I think it's improved quite a lot now and is a little bit easier to use, particularly if you're just wanting to supply a lot of the mandatory fields. So this is something that I have put together after the workspace that I just showed you there, where you can see on the left, there's a little bit to look at, but you can see on the right, this is the writer, and you don't have to just feed everything into one. It's broken down all the components for you, so you can only feed the parts that you need or you're aiming to achieve with the BCF. And on the left, you can see I've started preparing comment, viewpoint, topic, that sort of thing, where it's just generating some IDs and stamping some dates and creating some attributes that are specific to each of those BCF components. So the more interesting one, I think, just because it requires more, is the topic. So this is the attribute creator that I did for topic, where on the left you can see just the different attributes in the schema that it has, and then on the right I've just put some values in there for priority and status, but then the assign to and the creation I've actually put as a user parameter. So if you were to run this to do a validation, you can actually put who the author is there, and whoever needs to deal with this can be recorded as well. And then when that's actually read back in, because you can obviously read BCF with the reader as well, you can see on the left here in the display control that whatever attributes are used in the different components of the BCF, it will actually pre-populate it for you. So on the right, I only populated 4, but then when I've read it back in, 6 have popped up because it automatically records the version, and because I filled a priority, it's done that as well. So it's quite intuitive, and yeah, it's just a good platform for reading and writing BCF files as well. And just before I go, I didn't want to leave without giving a shout out to the example gallery as well, because it actually gives you an example workspace for reading IFC files and actually writing them out into shapefile. And it's put in a HTTP caller there for both IFC version 4 and 2 and 2.3. So a little bit, not quite up to 4.3, but still a very grab and go workspace that you can work with, where obviously the files are downloaded from a URL and don't really require too much configuration. And if you've never heard of the example gallery, it's a gallery that you can access via the help toolbar in FME form. And yeah, you basically just type it in and it will give you examples to different workflows. There's probably about 200 in there or so. And that's all from this presentation today about IFC. So I'll hand it back to Daniela now, and we'll go through some of the questions that have come in.